Hello, 8 Purple. Alright, so the purpose of this video is for those of you who can't get your Flash animation to work, and so I'm going to play around with the simulation in a way that would kind of mimic the questions that are being asked on the exit ticket and also at the same time as the worksheet because they're the same thing. So, alright, let's get started. First, I'll set this up as a new moon. You can see that there's a couple displays here. This big one right here that shows the moon's position in Earth as it orbits Earth. And as I take my mouse and move it around it, you can see how some other things are changing on other displays. So over here, you can see what the perspective of what the moon would be like from someone who's on Earth, who might be looking at the moon and rotating around. And this also tells you how much of the light is being reflected towards Earth. So right now we have about, what is this, about 25% of the moon's light is being reflected towards Earth. And if we go to a full moon, then we would see that 100% of it is reflected. And if we go back around to a new moon, then zero of the light that's hitting the moon is reflected towards us. It also tells you the amount of time that's passed since a new moon. So here's a new moon at 0 hours, and as we progress this way, we have hours and days, and it's just a counter that tells you about how long it takes for the moon to revolve once around Earth, right? So that's what that shows. This horizon diagram is kind of interesting too. It gives you the perspective of, I don't know, just like up in the sky, and what the angles of the moon and the sun would be like to someone who's on Earth. So as the moon rotates around, this is kind of more like a day-to-day thing. So if I increment by the time, if I increase by hours, you can see how the sun and the moon move across the sky. And if I increment by days, they something different happens. But I'm not going to get into that. Um, this is kind of nice. This diagram options, you can show the angle at which the moon is reflecting light towards the Earth. You can show a little lunar landmark so you can see what you might be seeing. That's kind of useless in my opinion. And then lastly, you can show some time marks, which is pretty nice because the person shows what time it is. So for this person, they would be experiencing sunrise, then noon, then sunset, and then midnight. This is similar to a model that I had you guys create a few weeks ago. So, all right, let's get started with what's happening here. All right, our first question, it's basically asking how many degrees does the moon move in a single day? So to answer that, I'm just going to increment it by 1 day and show the angle. Um, and there's your answer. That one's pretty straightforward. All right, number two. When the moon is waxing, does it appear ahead of or behind, kind of trailing the sun? So let's set this to a waxing crescent. We're waxing right now. And the best way is to look down at this animation right here. So if we start this animation, let's see, we'll slow it down a little bit. Let's see. Does it look like the moon is trailing or ahead of the sun? All right, you should be able to see that. You can change this, our perspective like that. Okay, and let's switch this to a waning moon because that's the next question. And we're going to see if the moon is trailing, if is it behind the sun or is it ahead of the sun? Right, so you can kind of see that right there. Okay. Okay, these next series of questions has you take a look at a diagram and it's going to match up. I'm going to use this horizon diagram to kind of match up what it should look like. So let's take this, the moon. Let's see, let's get us to uh, daytime, right? So the sun is right on the meridian like that, but the moon isn't quite there. The moon's more like this. Okay, so that basically matches a diagram that you should be looking at on your picture or on the exit ticket. That's about the setup. And so from here, you can kind of figure out what's the moon phase, um, what time it is, and then lastly, when might the moon be when might the moon be overhead? So to do that, the moon will be at its highest point when it's directly above this person. So I'm going to change this there. And you can kind of pretty closely see what time it is for this observer right there. That information is given on one of these displays. So you might have to pause the video and hunt around for that. All right, and so for the last bit of questions, what you're given is you're shown like a model of where the moon is in its orbit around Earth and which direction the sunlight is coming from. Now it's super important that you pay attention to the direction of the sunlight because it's all relative to that. A new moon will always occur between the earth and the sunlight. So you've got to make sure that you're orienting your model correctly. So in order to do this, all you need to do, what I'm going to do is I'm just going to play this. I'm going to set this equal to zero to the new moon, and I'm just going to play the animation once all the way through. Now you might want to pause it or rewind or fast forward, but that will give you all the information that you need. So here we go. I'll be quiet and I'm just going to let the animation run for a complete cycle. I'm going to do some heavy breathing for you guys so as to distract you. hmm Interesting. Oh, yes, I see now. Oh, now it's making sense. Wait. Oh, but of course. That makes perfect sense. hmm I agree with that. Oh, this is just fantastic. Absolutely. Yes. Yes. Perfect. I can't get enough of this. This is just absolutely amazing. Okay, and there we go. So what you may need to do is just to pause the animation or pause my video back and forth, and that should take care of everything. Please email me if you have any questions.